For most of us, the Earth's magnetic field is something we don't think about. It's abstract, invisible, the answer to a trivia question about why a compass works. Or maybe you think of the Aurora Borealis, the Northern Lights, a beautiful, silent, celestial light show. It all seems very calm, very stable. It feels like our planet came with a built-in passive defense system, like a pre-installed antivirus program. A gentle, reliable force field protecting us all. Now, look at this. A churning, raging, sloshing ocean of liquid iron, hotter than the surface of the sun, swirling with chaotic, violent energy deep inside the Earth. So, what if I told you that the calm, beautiful light show in that first picture is created by the raging, unpredictable monster in the second? What if I told you that our planet's north and south poles have played a game of musical chairs hundreds of times, flipping upside down again and again, and that they might be getting ready to do it again? Is the Earth's magnetic field our stable, silent guardian angel? Or is it a chaotic, unpredictable beast that's starting to act a little weird? First, let's give this hero the credit it deserves. The magnetic field is, without exaggeration, the single most important thing you've probably never thought about. It is Earth's superhero force field, our planetary shield, and the only reason life as we know it can exist. Its primary job is to be the planet's bouncer. The sun, our friendly neighborhood star, isn't just a gentle ball of light. It's a raging nuclear furnace that is constantly blasting out something called the solar wind, a relentless, high-energy stream of charged particles flying through space at 1,000,000 miles per hour. If this cosmic sandblaster were to hit Earth directly, it would be catastrophic. Over time, it would strip away our atmosphere, molecule by molecule, until our planet was left naked and exposed. It would boil our oceans and bombard the surface with so much deadly radiation that life would be impossible. If you want to see what that looks like, just look at Mars. Mars used to have a magnetic field, but for reasons we don't fully understand, its core cooled down and the field died. And without that shield, the solar wind has spent the last few billion years blasting Mars into the cold, irradiated, barren desert we see today. That was almost our fate. But we have the shield. It extends thousands of miles out into space in a vast, invisible teardrop shape called the magnetosphere. When the solar wind hits it, it gets deflected. The shield stands firm, and this river of deadly radiation is forced to flow around our planet. It's like a scene from a sci-fi movie, happening on a planetary scale, every single second of every single day. The only time we really see this epic battle is at the poles. The magnetic field lines funnel some of those solar wind particles down into the atmosphere near the north and south poles. When these high-energy particles smash into atoms of oxygen and nitrogen in our air, they get excited and release that energy as light. And that is the aurora. Every time you see a picture of those shimmering green and purple curtains of light, what you're really seeing is our force field violently body-slamming particles from the sun. It's the beautiful debris from a cosmic war we'd otherwise never know we were winning. So, a silent, life-saving shield that also puts on the best light show on Earth. It's the planet's unsung hero. It seems so stable, so reliable. But to understand where it comes from, we have to travel to the center of the Earth. And things are not calm down there. For most of human history, the most important feature of the magnetic field was its incredible reliability for navigation. The simple, almost magical fact that a magnetized piece of iron, floating in water or balanced on a pin, will always point north. The compass was the key that unlocked the planet. It allowed explorers to cross vast, featureless oceans, to map continents, and to build the interconnected world we live in today. Its power was in its predictability. North was north. End of story. And it's not just us. The animal kingdom runs on this invisible infrastructure. Migratory birds, like the Arctic tern, use the magnetic field to navigate their incredible 50,000-mile round-trip journey from the Arctic to the Antarctic and back. Sea turtles hatch on a beach, spend years roaming thousands of miles of ocean, and then use the Earth's magnetic field to navigate back to the exact same beach where they were born. Salmon do it, bees do it, even some bacteria do it. They have a built-in biological compass, a sense called magnetoreception. The magnetic field is the invisible highway system for half the life on our planet. All of this, from the first sailors to the last sea turtle, depends on one crucial idea: that the field is a stable, dependable guide. A cosmic signpost we can always trust. But this entire stable, reliable system is generated by the most unstable, unreliable thing imaginable. And the history, written in stone, tells a very, very different story. So, where does this field come from? It's not a giant bar magnet that someone shoved inside the Earth. The truth is much messier and much more amazing. The Earth's core has two parts. The inner core is a solid ball of iron and nickel. But the outer core, which surrounds it, is a massive 1,400-mile thick ocean of liquid, molten iron and nickel. It is a raging, sloshing, turbulent sea of metal, hotter than the surface of the sun. As the Earth spins and as heat radiates out from the inner core, this giant ocean of liquid metal churns and swirls in massive, complex convection currents. Because moving metal creates electrical currents, and electrical currents create magnetic fields. This process, called Breuerhold the geodynamo, turns the entire core of our planet into a giant, self-sustaining electromagnet. The field we experience on the surface is just the smoothed-out, averaged-out effect of that raging, chaotic mess thousands of miles below our feet. It's not a calm shield. It's the whisper of a subterranean hurricane. And because its source is so chaotic, the field itself isn't stable. The magnetic North Pole, the spot your compass points to, isn't a fixed geographical location. It's a drifter. For 100 years, it wandered slowly around northern Canada, but in the 1990s, it started moving much, much faster. It has now left Canada entirely and is sprinting across the Arctic Ocean towards Siberia at a clip of about 35 miles per year. This isn't some abstract scientific fact. It has real-world consequences. Airports have had to repaint the numbers on their runways, and the models for GPS and other navigation systems have to be constantly updated to account for our planet's shifty magnetic personality. But a wandering pole is just the beginning. The really wild part is written in the rocks. When a volcano erupts, the lava that flows out is full of tiny, iron-rich minerals, most notably one called bagnetite. As the lava cools and hardens into rock, these tiny iron particles act like microscopic compass needles. They align themselves with the direction of the Earth's magnetic field at that exact moment in time, and then they are locked in place. The rock becomes a permanent snapshot, a fossil of the magnetic field. It's like a geological tape recorder. By studying the layers of volcanic rock around the world, geologists have been able to play that tape back. And what they found is shocking. The magnetic field doesn't just wander, it flips completely. North becomes south, and south becomes north. It's called a geomagnetic reversal, and the rock record shows clear as day that it has happened hundreds of times in our planet's history. It's not an instant switch, like flipping a light. The process can take thousands of years. The field first weakens, becoming much less powerful than it is today. Then it gets chaotic. Multiple, weaker north and south poles might pop up in random places all over the globe. A compass would be useless, spinning aimlessly as it tried to decide which north to point to. During this transitional period, our planetary shield would be at its weakest. More solar radiation would get through, potentially damaging our satellites, disrupting power grids, and posing an increased risk to astronauts and even frequent flyers. The beautiful auroras might not be confined to the poles. They could be seen anywhere, even at the equator. And what would it do to all those animals that depend on the field for navigation? We just don't know. The last full reversal happened 700 to 80,000 years ago, long before humans had satellites or power grids. We are overdue for the next one. So, what are we left with? A guardian angel with a serious chaotic streak. The paradox of the magnetic field is that the very chaos that makes it unstable is the secret to its existence. The calm, protective shield we enjoy on the surface is entirely dependent on the violent, churning engine in the core. Without that chaotic, sloshing ocean of iron, there would be no shield at all. The field's instability isn't a flaw. It's a feature. It's a sign that our planet is geologically alive and dynamic. A dead planet like Mars has a cooled-off, solid core. It has no churn, no chaos, and therefore, no protection. So the wandering pole, the wobbling field, and even the terrifying prospect of a reversal are all, in a weird way, symptoms of a healthy planet, a planet active enough to sustain a shield that can foster life. The chaos is the protection. So the magnetic field isn't a perfect crystal shield. It's more like a flickering candle in a storm. It's generated by a chaotic dance of fire and metal. It wavers, it wanders, and sometimes it even blows out and relights itself in the opposite direction. But it's that flickering, unstable, chaotic flame that has kept our world warm and safe from the cosmic storm for billions of years. If your own internal compass could point to one thing to guide you, what would it be? Let me know in the comments. And if you enjoyed this look at our planet's weirdly brilliant force field, be sure to subscribe to the Weirdly Brilliant channel. We think you'll be attracted to our content.